All right, hello and welcome back, ALEKS students. So this is another ALEKS topic that's called drawing a box diagram of the electron configuration of an atom. It's a nice little topic. It's fairly straightforward, but I think there's a number of different things that we should be thinking about as we're doing a topic like this. And basically just to orient you to the tools that we're going to be asked to use. Here we've got a box orbital essentially that represents an orbital, and I can place that in my diagram here. And as I place it, at a higher energy level here, you'll notice this label here. So as we go from, this lowest energy level up, that's going to represent the different energies of our orbitals. And of course, we'll talk a little bit more about, what that means. First and foremost, so I'm going to go ahead and fill in this lowest energy orbital. That's always going to be the 1s. So I can just go ahead and do that. And then as I would be putting in our other orbitals, if it's the next orbital is at a higher energy, we're going to put it higher up on the diagram here. So why don't we go ahead and do that one? That's going to be the 2s. So for the other ones, I will actually talk about how we come up with those and sort of how to remember what the order of those are from the periodic table. It's actually really straightforward if we just look at a periodic table. So I'm going to go over here to our periodic table icon and basically just look for argon first and foremost. So we're going to be filling in the electron configuration for a neutral atom of argon. So I can find argon over here. I know that this number above it, that represents the number of protons. Since it's a neutral atom of argon, that also tells us the number of electrons, because the electrons and protons should equal each other if we're talking about a neutral atom. Therefore, we're going to have 18 electrons that we're going to need to fill in our full box diagram. Then the next thing I would look at or sort of start thinking about is the orbitals that we're going to need to fill in. So when I look at a periodic table, I know that these two, sort of this first two groups, the first two columns here, those represent the s orbitals essentially. As we're thinking about the electrons that are filling in for lithium or beryllium or sodium or magnesium, those are going to be the s orbitals. So these two columns represent the two electrons essentially that can fill in an s orbital. In the middle here, these are our transition metals. These are going to be where the d orbitals are. So again, when I'm looking at this periodic table, in my mind, I'm sort of seeing s orbitals here in the first two columns, d orbitals here in the middle section, and then over here are the p orbitals, right? And then in terms of the labels and sort of the levels that we're going to go through, so hydrogen, helium, helium's a little bit weird that it's over here, but that's also going to be, representing the s orbital if we think about the electron configuration for helium. That's just 2 electrons in that lowest level 1s. Then we're going to go to 2s. So basically what we're going to do is we're going to read this. We're going to read the orbitals off of this periodic table from top down, left to right. So here's what it looks like. This would represent the 1s. This represents the 2s. So, we're just counting down from 1, 2. Now over here, this represents the 2p. That's the lowest energy level p orbitals are 2p. Then we just go back over here, 3s, 3p, that's next, 4s, now 3d. So now we're into the d orbitals, the lowest energy d orbitals 3, 3d, and now over here we're at 4p. So you don't have to memorize the ordering of the orbitals, you just have to read it off of the periodic table basically. So I'm going to go back to our palette here, I'm going to start filling in our other orbitals. So I know that next is 2p. And that there's 3 of those, so I'm going to do 3 boxes here. Next above that is our 3s, and then we're going to have our 3p, and we're going to have 3 of those again because they're p orbitals. Now I might pause to sort of see how many, go back to this periodic table and figure out how many am I going to need to do. I probably should have done that first. So to get to argon, I basically need to fill up my 3p orbital. That's all I'm going to get here. And I don't need to worry about anything below that. If I were to continue this diagram, next would be 4s, then 3d, then 4p. Again, just reading this top to bottom, left to right. But now I know that I've got enough of my, my diagram filled out. I can start putting in the electrons. So the most efficient thing to do is just to put in all of our upspin electrons first, and then we'll put in our downspin electrons to fill out our diagram. And then the last thing we're going to do is we're going to count all of our electrons that we've got in our picture. So we've got 1, 2, maybe I'll switch the tool so it's not as confusing. Well, that's confusing as well. Maybe I'll do it this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 6 more is 18. So if you just count all of these, each one of these represents an electron. and we're filling in from the bottom up. And this is our diagram. So let's go ahead and check that. And we'll do one more really quickly just to get through this learning progression. So here for a neutral atom of fluorine, so do pay attention to what we're told here. If it's an anion, we're going to be adding in electrons. If it's a cation, we're going to be taking away electrons from the neutral atom. So fluorine, again, I'm going to go to my periodic table. Fluorine's right here. So this one's should be pretty quick. I've got 1s, 2s, 2p. That's all I'm going to need. So let's go ahead and build those. Here's my 1s. Here's my 2s. And then next is going to be 2p. Go ahead and fill those in. Now my electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know that I just remember that fluorine is 9, and so that's how I knew that. But if we want to double check, we can always go back to our periodic table. Fluorine has 9 protons. Neutral atom would have 9 electrons. So in my 2p, I'm only going to have 5 electrons filled in. And so then this is what that should look like here. I'm going to use this tool again so I can sort of draw your attention to it without making it too confusing. So hopefully that makes sense how to do this topic. I guess the other thing I will mention is if this were talking about an anion, a fluorine with a -1 charge, that -1 would just indicate that there's an extra electron. That there's one more electron than there are protons. So I would just add in another electron here, to have that electron configuration of the anion of fluorine. So hopefully that makes sense. All right, thanks very much.